identification using proper scientific nomenclature. Surprisingly often people want to capitalize everything on their title page. If you capitalize all of that, it's wrong. Yes? Because it's not proper scientific nomenclature, so don't do that. This is the table of contents. Now this is from this summer. We've changed what we do, so there's a few things that are going to be different. The descriptive chart is page 1. So for you guys, that's true also. The next thing is going to be your strike charts. If you're only on one strike chart, your strike chart is going to be page 2. If you're on 2 strike charts, it's page 2 and 3. 2, 3, and 4. Okay? So put your descriptive chart, then put your strike chart. Then comes your flow chart. So it's different from the order that this person did it. Your flow chart should be probably 2 to 4 pages, depending on your organism and the way your strikes went. So descriptive chart, strike chart, flow chart, then you're going to have your journal. After your journal, you're going to have, and this person did it wrong, you're going to have your citations, your work cited. After your work cited, you're going to have Appendix A, which is your test explanation sheets. After that, you're going to have your Appendix B, which is the extra pages copy that you're putting on the end. Everything except your data manual. Okay, everybody got that order?
We might not have an Appendix B, though, right?
What?
If we did all our tests out of the lab manual, we won't have Appendix B.
Yeah, some people don't. But you have to have at least 3 site sources. So sometimes you gotta find one.
Okay.
You could go look up something about your organism and write a paragraph at the end. You don't have to, and then append whatever you use as your source there. Cell size and habitat, you must, yes. Those are the particular ones that we instituted this process for. And I'll show you a folder here at the end. Okay, descriptive chart, that's where your grade's going to go. I would not have given this person a 99, but probably a 97. The things that are needed to be on here. You got to have your name. You've got to have your organism completely spelled out. Do not abbreviate that genus. Staphylococcus psilosis. It has to be italicized. Right? I'm the source. I gave you the organism. If you had been collecting from the field, it would have been wherever you had collected from. And then culture number. The morphological characteristics is from all of your staining. So shape, arrangement, cell size is from Burgess. You're going to go look it up. You're going to use the species cell size. If you can't find a cell size in your species description in Burgess, you default back to genus. But don't go to genus first, because if there's a cell size for species and you do genus, it's wrong. Okay? You have to get familiar enough with Burgess to be able to go find the cell size and the species description. For all of the test results, you've got to give me a description and an interpretation, always. So for gram reaction, you can't just say gram positive. You've got to tell me purple. Okay, it's points off if you only have positive. Motility has to have whether it's motile or not, and then the temperature at which you tested. Some of our organisms are motile at one temperature and not another. If you did any special stains, you'll describe them. Otherwise, you just put NA. Cultural characteristics have to do with growth. So here's your colony size that you measured on your 4-quadrant streak that first day. We all pulled out rulers and measured. Then you're going to give me the colony characteristics here from the agar plate. If you did hemolysis, you're going to tell me about that. You're going to tell me from the agar slant what your characteristics were and the broth read. All those are required, as motility is required. Even if you didn't need to do motility for your identification, you have to have a motility. Even if you don't have an FTM for your identification, you have to have an FTM. So optimum temperature and oxygen requirements have to be here, so strictly aerobic. Optimum temperature, 37 degrees. All of this must be in your journal as well. proper way to have done this would be to record all your results in your journal, then transfer it to your descriptive chart. If you did anything else with growth, such as various pHs or temperatures, if you did antibiotic resistance, it goes here under Other. If you did the serology with Salmonella, it's going to go here as well. It belongs in the cultural characteristics. For many of you, this will be a big blank spot you might use if you overflow from some of these tests on the other side. You get the habitat from Burgess. Now, you are not going to write Burgess up here. APA style, you've got to have the authors, or in this case, the editors. So depending on which volume you have, you either got DeVos or Garrity, and you're going to place it up here. And you might have to abbreviate it, but there's not much space. Then you come to the physiological characteristics, which are all the tests. The first part of the column covers fermentations. Nothing in this list should be something other than, everything on the list should be a fermentation. And these are, for the most part, phenol red broths. You might have gotten it off your KIA. There are no media names on this. So you're not going to tell me phenol red arabinose. You're going to tell me the test, which is arabinose. And you're going to tell me it's positive. For acid, it was yellow. Describe and interpret. Cellobios, negative pink. You put all your sugars here. You have two options. You can put them alphabetically, as this person has done, or you can put them in order of inoculation. So one after another, day after day. Do not just randomly pluck sugars down on this list. You got those two options, alphabetical or chronological. Right here. And you keep going. Now, this is for other physiological tests other than fermentation. And there's some pre-printed on here. You can keep those on there, and if you didn't use them, just put NA. Or if you need the space, you can delete them and put some of your own in there. All lab exercises tell you what type of reaction is going on. So there's no excuse not to get this right. If it's a fermentation here, if it's a hydrolysis, it goes down below. The IMVIC tests go here in the center for the IMVIC label. So this is going to be a lot of your tests from oxidase, catalase, sulfide production, nitrate reduction, arginine dehydrolase, lysine decarboxylase, ornithine decarboxylase, all kinds of things you might have done. And it just is the fermentations you're going to add going down the list, the others you're going to add going up. If you run out of space, you come over here and you head it, and you might need more room for fermentation, so you head it fermentation and then put the rest of them here. Or head them other physiological tests and put them here, so that you'll have room, so you don't go to a second page. The IMVIC series was important for our gram-negative rods, and that has its own special place on a standard descriptive chart here. And the hydrolysis reaction, so this would be the gelatin, the lipase, urease, belong there. Okay. And again, you're putting test names. And you're putting a description and an interpretation. In most cases, the description is a color. And then a positive or negative. Okay? Questions on that? So this is all typed. You can do this fairly mindlessly as you're going through your journal or your pre-printed or the descriptive chart you've been working with. Not everything in here needs a whole lot of thought. So your strike charts are going to come next. I want your strike charts printed. You can print and you don't have to print color, but if you print color, the only color is what Terry put on here. Okay? You're not going to take a color marker anywhere, and you're going to use a pencil, a dark pencil line to draw your strikes. So you're going to give me a clean strike chart. You don't need to have any of the wavy lines to eliminate. I'm going to be going through the chart myself and working every test. But give me every one of your strikes. Give me on the side what I'm recommending everybody do, which is your test result here, and then strike the opposite. Okay, so a clean strike chart. This person used 2 because the staff chart is not sufficient for this group. They also have the Micrococcus, Planococcus, Spora Sarcina chart, which if you're on this list, you know, right? If you're a gram-negative rod, you've got a 2-pager. If you're a gram-negative rod with Salmonella, you got 3 pages of strike chart. That comes after your descriptive chart. And then comes your flow chart. For the flow chart, you're going to start with the gram stain charts right back there. See them up on the incubator? Remember your gram stain charts? That's how you knew which species chart to get onto. Everybody's going to start with the same basic test. Gram reaction is first. So this is one way to lay out your flow chart. So the first thing you do is gram reaction. You tell me what the result was. So there's positive. Okay, gram reaction, positive. You're going to have two columns, possible, eliminated. There are 11 groups on those gram stain charts, and you must have 11 names here between these two columns. This person's gram positive, so there are, I'm sorry, there's 11, there's 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 gram positives, 4 gram negatives. You must have 15 names in total. That is 2. That's 2. Listeria is one genus, Kerthia is a second genus. Yes, it is. That's why I'm emphasizing that, because that's a lot of confusion. Some people think they only need to put Listeria. You need to put every genus, or genus and family in the case of Enterobacteriaceae. Okay? So if you're gram positive, you're going to have 11 possibilities and 4 eliminations. If you're gram negative, you're going to have 11 eliminations and 4 possibilities, right? Once you have eliminated, you don't have to consider those again. They don't show up again on your flow chart. So first is gram reaction for everybody. The second is morphology. This person has coxy. So they're looking at the gram positive gram stain chart, and they're going to look at the coxy versus the rods. Here's a list of the coxy. There are 6 genera that are coxy, gram-positive coxy. There are 5 genera that are gram-positive rods. So all 11 are accounted for here. So once they have got this done, what's the next test for a gram-positive coxy on the gram stain charts? It's catalase. If you've got a gram-negative, you're not doing catalase. What are you doing if you got a gram-negative at this point? FTM for oxygen requirement. And these are test names, not media names. So catalase, they got a positive. You've got to tell me the result over here. And so that eliminated the Streptococcus and Enterococcus. And what's in Staphylococcus, Micrococcus, Planococcus, and Spora sarcina. Staphylococcus is one chart. These 3 are all on the same chart. So this gets you to the species chart. So then you pull your species chart out. And you look to see which test gave you the most strikes. For this person, it was Xylose. Xylose eliminated all but 3 on the staff page. Right? Lots of tests gone. And if you look at it, but it did not. It's not even on this page, so it didn't eliminate anything from here. So all of these are still possible. And those 3 staff. So here's a list of all the species on the Micrococcus, Planococcus, Spora sarcina chart, and those 3 staff that remain. And all of them are listed here. You have to spell these right and do proper scientific nomenclature. At this point, they're all genera. That means they're capitalized. They're all italicized. Once you get onto the species chart, you've got full scientific names. So there's Micrococcus luteus. So Micrococcus is capitalized, luteus is not. The rules allow you to abbreviate the genus after first use. I recommend against it. You're mostly just going to be copying and pasting these names. You're not going to have to type them all out all by them fresh every time. So what I recommend is you write the whole thing out, because unless you're particularly good at scientific nomenclature, it's real easy to make an error, and every error in nomenclature is 1 point off on your paper. Okay? If you eliminate the entire genus, you could just put the genus and then put SP. So it would be Shigella SP period for the Shigella species.